Good evening, everyone. I'm Madan Nitiraj. I'm one of the founding members of Apache Ranger. I've been working with Ranger for 4 years, and I've been working with Atlas for a couple of years. I'm PMC on both. And I work at Hortonworks, leading security and governance engineering team.
Thanks, Madan. Can you hear me? Yeah, so I'm Dr. A brief background about myself. Along with Madan, I was the founding member of the Apache Ranger project. I'm also a committer in Apache Ambari. Currently, I'm a co-founder of Pravasara. At Pravasara, we do security for that modern data architecture. We discover your voice is breaking.
Yeah, it's just,
Mic is not right.
maybe you stay here.
Got to give me that. Wait, hold on.
Turn that off.
Okay.
Yeah. So at Pravasara, what we do is we do security for the modern data architecture. So we auto-cover sensitive data and personal information, and we take the necessary action based on the classification. That could be protecting it by anonymizing it, encrypting it, also setting the policies in a hybrid environment. So this is the standard disclaimer. So today, Madan and I are going to talk about how you can secure a hybrid environment. So, and also we'll have a demo following that.
So you can see the red bands and the yellow bands and orange bands there that you look through.
More and more business enterprises have started getting into the hybrid environment. So there's a lot of good reasons behind it. Different workloads can perform better in different environments. Also, there's a lot of cost benefit for certain workloads in on-premise, as well as some workloads work better in the cloud. And also, if you in the cloud, you have certain tools that's available which you can use. Like if you go for Amazon, they have a lot of analytical tools which you can use. And also, certain use case makes better on-premise, and certain use case works better on the cloud. Like if you most of the enterprises are doing data ingestion, ETL on-premise, and so also running long-running services like Hive on-premise, and they're doing the BI and other data warehousing workload on-premise. At the same time, some groups might want to use the compute power of the cloud. So what they do is they transfer the data from the premise to the cloud and run analytical jobs in the cloud. Also, in some cases, where you might have to share some of the data to third-party vendors, at that time, it's much easier to share it from the cloud. But now you have two different environments. So you have to maintain the security on both the sides, and that could be pretty challenging. So at the bare minimum, you want to make sure that the access permission is consistent on both the environments. That means if I don't have access to certain data on-premise, if that data moves to the cloud, then I should not be able to access the data in the cloud. Similarly, there could be some other policies or regulations from your corporate or from your regulatory, where will dictate how you can store the data in the cloud. And in most cases, the in-house IT and security may not have full control or visibility of your cloud environment. So in that case, it might be just safer to tokenize or anonymize the data before moving it to the cloud. But implementing security in the hybrid environment is pretty challenging. There are a couple of reasons. First of all, the permission model on the cloud is very different than what it is in the Hadoop environment. Secondly, the user and group definition are inconsistent between Hadoop and the cloud. And when it comes to big data, data is constantly moving within the cluster. So that means now you have to keep track of all the sensitive data within the cluster and all the permission which is associated with it. Now, if you're moving that data into the cloud, then you have to also move the same policy to the cloud. So that could be pretty difficult, and in some cases, could be also very much erroneous. So the good news is Apache Ranger was built from ground up to solve exactly the same problem, but in the big data environment. Even in the big data environment, you have data moving across within the cluster. You might have HDFS file in the HDFS, then you may have a table on top of it using Hive, and you may use BI or JDBC to access it. And the same table can be accessed using Spark or Pig by just connecting the metastore, get the metadata, and access the file directly. So Ranger, along with Atlas, is already solving it using the tag-based policy. So it's much easier to just leverage Ranger and extend it to the hybrid environment. So what Madan is going to do is going to go a little bit detail and see how we are doing it.
So let's take a look at a typical hybrid environment. On the left-hand side of the screen, you have on-prem Hadoop cluster where HDFS, Hive, Ranger, Atlas, and some discovery tools like Pravasara and Hortonworks Data Steward Studio are running. On the right-hand side, you have S3 where the data will eventually be copied. So we'll look at the flow of data as it enters into the Hadoop cluster, as it gets processed, and it moves into S3 cloud. So raw data enters the landing zone into the cluster. And as soon as the raw data enters, discovery tools like Pravasara or Hortonworks Data Steward Studio, they scan the data for any potential sensitive information. And whenever they find sensitive information like email address or phone numbers or address or maybe social security number, then the discovery tools add appropriate classification in Atlas. So at this point, you have information about what the data, metadata about the data which came in and the classifications which are discovered about this data. Now the next step is some ETL process will take this data from the files and then load it into Hive table, which users can do further processing, further query. Now, as the data goes into Hive, there are a couple of things. So here we have a raw file which had a bunch of data including names, some sensitive, some non-sensitive information. But when it goes to Hive, it can do more fine-grained discovery. Like if the data has 100 columns, maybe like 20 columns are sensitive with a different level of sensitivity. Now the discovery tools can go and look at the data in each of these columns and associate the correct level of sensitivity, the classification for each column level. And again, this classification at the column level is also stored in Atlas. And the second part, there's an Atlas hook. There's an Atlas hook running in Hive, which monitors for various operations like table creation or data loading or data getting exported from Hive. And then it creates metadata and lineage in Atlas. So in this case, the Hive hook will capture the fact that data was loaded from a file, from HDFS, into a table. So that's a lineage created. So we'll see all of them in a demo later. We're just going to walk through the process. Okay, so before we come to this, so let's assume that the discovery tool identified a couple of sensitive columns here. One is a name and the personally identified information, and the other is address. And it added appropriate classification in Ranger. And Ranger has provides policies to enable authorization based on the classification. So if a field is classified as, let's say, PII, personally identifiable information, you can write a Ranger policy to say who all can access the information. And the second part is Ranger also provides policies to set appropriate data masking based on the classification. So if a field is identified as, let's say, credit card number, then certain users will be, you might want to allow only last 4 digits to be seen. All others you want to be masked. And for some users, you want to show the complete credit card information. All these policies can be set in Ranger via classification-based policies. Now, in this case, we are going to talk about 2 users. One is Sally and Mark. And Sally will have access to all the information in clear text, whereas user Mark will be able to see only anonymized or tokenized data. So you can see both the users, they'll be running the same query on the table. When they do it, the Ranger authorization policies will apply appropriate masking and appropriate authorization. So next, the data gets exported into S3. So the mechanism we are going to walk through about export is via Hive export command, which is insert into a directory the result of a query. So there are quite a few benefits in doing this way. First of all, you can restrict by Ranger policies, who all can write data into S3. So basically, you go to Ranger for a given Hive, you can set a policy saying that okay, only S3 ETL user. Let's assume you have a user called S3 ETL. That's the only user who can write to S3. And any other user, if they want to export data from Hive, they'll be denied from the operation. So you can control that. And the second part, you can apply appropriate data masking policies for this user to make sure that no sensitive information gets exported into S3. So whatever the access control in place for Mark, the same access control can be set for the ETL user. Thereby, you can be sure that no sensitive data will get exported into S3. And the third part is, if your cluster has really highly restricted information which you never want to go into copied into S3, so you can classify that information as highly restricted, and you can set up Ranger authorization policies to deny explicitly access to S3 ETL user. So if the user tries to export the data even by accident, and then the user will be denied from being able to access the data. So now once the data is copied, there's another component here which is S3 ACL sync. That component will look at the classification associated with the S3 destination, okay? And then it'll go back to Ranger. And if the S3 destination is tagged as PII, it'll go to Ranger and look at all the access control for this PII classification. Then it'll make an API call into S3 and set the ACL for that. So this is all automatically be done. So as soon as the data is copied, the ACL also will be set in S3 itself. Okay, Bhaskar, you want to go through the demo?
You want to talk about the policy sync first? And then?
Okay. Policy sync comes later.
Okay.
Okay.
Why don't you finish the policy sync?
Okay. All right. So we'll look at this ACL sync in a little more detail. So the ACL sync module is just recently being developed, right? So it monitors Kafka notifications from the cluster. The notification includes information about what type of entity it is and what is the qualified path for the entity and what the classifications are associated with this. So when once it receives this notification, it goes to Ranger and looks for the permissions for the sales classification, which users have read and write access to it. Then once it collects the information, so you can see from the policy there, users Sally and Mark have read access on S3 permission, right? So it gets the information from Ranger and it makes API calls into S3 and sets this permission on S3. And this is a sample ACL set on S3. Once this ACL sync process makes an API call into S3. Okay. Yeah.
Okay. So now we'll go to the demo. So before we start the demo, let me set the context. So for this demo, what we're going to do is we're going to use a sample data set from a sales output. We have item ID, we have amount, we have some personal information like email, name, and address. And as Madan said, we'll have more than 1 or 2 or 3 user types. So we have Sally user type who's from the sales group. So she has all unlimited access on the data. So she can see all the data in clear. Now we have Mark from the marketing who wants access to this data. So he has access to the data, but he can only see the anonymized data. And we also have Henry, who's from the HR group, and he has no access to the sales team. So what we'll do is we will use this data as our sample and go through the flow that Madan explained. So before we go there, let me show the Ranger policies.
I'll hold it. It's not showing up there, though.
So the one new thing you're going to see out here is the S3. So this is a new service dev that we added into Ranger. So similar to HDFS and other ones, we have a new service dev called S3, which will be used for setting the tag-based policy. And if you're already familiar with tag-based policy, we're going to just reuse the same thing. So what we'll do is we'll set up some access policies on a tag called sales. So Ranger has two types of policies. One is the access type, and second is the masking. So for this demo, we'll be using both of them. So let me get into the sales policy. So what we have here is a tag called sales. So this is more like a business tag. So any data which belongs to sale will be automatically tagged as sales. So we'll have access policies around it. And what I've done out here is for Sally and Mark, I've given access, read access to this data in HDFS, Hive, and also in the S3. So the get is an equivalent of read in S3. So once you set this policy, you're pretty much good afterwards, because any data which is tagged as sale, this policy is going to be enforced. Ranger also supports deny, so explicit deny. So what I've done is, for the user Henry, I have set up an explicit deny. So out here, so Henry, for all the components, I've given a global deny. So if Henry tries to access the data, either on the premise or on the cloud, you'll be denied. Okay. Now, once we have set this up, then let me go to the second set of policy, that's the masking. So the masking policy generally works on the Hive columns. So this is where you have all the security-related tags. So for each data type, you will have a tag. So we have a credit card number, I got person name, I got US address, email. So the reason you have so many of them, you can have different types of anonymization or encryption. So let me pick one of them. So I just picked email. So what I'm saying out here is, if any of the column is tagged as email, and either of this user make a query on the table, doesn't matter which table it has, then we will anonymize it. Okay. Out here, I'm using the UDF from Privacera. So in Privacera, we do anonymization, tokenization, and encryption. But you can also use your own custom UDF, and Ranger also comes out of the box a few UDF you can use. Okay. Now, when Mark makes a query in any table which has column which is tagged as email, it will be automatically anonymized. And one more thing you might see is there's another user called S3 ETM. So this is the user we're going to be using for transferring data from the cluster to the cloud. As Madan said, the advantage of this is you can set up all the policies, all your cloud-related policy, whatever transfer policy out here. So you can set anonymization based on this user. You can have rollover filter based on this user. You can restrict certain data based on this user. So it makes it much easier to manage at one single place. Okay. So once you have set up the policies, then pretty much you don't have to worry about it again. So all you need to do is do your regular thing. If you can get data into the cluster, it will automatically get scanned. Then you create a table. The tags will go into the table. When someone runs a query, it will automatically enforced. If you're moving it to S3, the same tag will go to S3 and will get enforced at the S3 level also. So for this demo, what I'm going to do is I'm going to do 3 operations, just what I just said.
You may need to move there if they want to see.
So I'm going to copy the sales data into the HDFS folder. And from that, I'm going to create a Hive table. And from the Hive table, I'm going to export the data to S3. Okay, and we'll assume that the tags are getting propagated and all the policies will go along with it.
It's difficult to type looking at them.
Give me a second, guys, sorry.
What happened? It's not getting the focus?
Oh, I think it got out of the VPN.
Oh.
Okay, I think you're good. So I have a sample data which has the item ID, the personal information like names, the email address, credit card number. So what I'm going to do is I'm going to copy this file into HDFS. Sorry, guys. I'm just going to use the regular HDFS command to copy. Okay. Once it is copied, I'm going to load it into Hive. So I'm just create a table out of it. So
I want to show it in Atlas.
yeah, so before that, let me just show what is in the table. So if I do a select query, you can see that I can see the first name, email address, and the state. So now let's see what's happening behind the scene.
Maybe you can stop the presentation. Right?
So behind the scene, what's happening is, so in this particular case, Pravasa is a background process. It's monitoring all the change requests that happens within the cluster. So since the table got created, what Pravasa will do is immediately scan it and tag it. Okay, sorry. So this is the dashboard for Pravasara. So it has discovers 75 elements, and out of the 75 elements, it automatically classified 74. What that really means is, when Pravasara does a scan, it has a confidence score, how confident it is actually sensitive information, and if it's pretty confident, it will classify it. So if you see some of the recent scans, so this is the table that I created, the sales May 2018. And for all the columns have been individually been tagged. So if I take something like an email address, you will see that it has two tags, sales and email. The sales is the business tag. What that really means is this data belongs to the sales group. And in Pravasara, we have a concept called data zone. So I have a data zone which says that any data within the data zone should be automatically tagged as sales. And this is a tag that will be used for the access control. Now, we also have another tag called email that is based on the field name email address. So what it did a content scanning and found out there's an email, it automatically scanned as email. And this same data will be available in Atlas.
Probably have to log in again.
Let's see. Yeah. So what has happened is, so Pravasara did the discovery, and it pushed the tags to Atlas. So if you see, all the columns are coming up here. If I click on email address, you will see the same two tags which was in Pravasara out here. And since it is in Atlas, the same tag will also go into Ranger. So from this point onwards, if anyone is trying to access Hive using Beeline, then the same policy will be enforced. So if Mark is trying to access it, the email will be anonymized. If Sally is accessing it, she will be able to see it. Okay. Now, what I'm going to do is, I'm going to put this data into S3. So I'm going to be using the S3 ETL user. Okay. So if I just run the select query, you can see that for this particular user, the first name and the email has already been anonymized. So that was the intention. So when this user moves any data from the cluster to the cloud, it will be automatically encrypted or anonymized. So what I'm doing out here is, I'm doing a select star from the sales table, and I'm inserting it into the S3, this location. Okay? So it's going to take a little while because it goes to S3. So what's going to happen out here is, when the query is run, the Hive Ranger plugin will automatically kick in and make sure that the appropriate UDFs are called and all the protection is done. And then once it is done, once it goes to S3, even the classifications will be tagged in the S3. So essentially, it doesn't tag at S3, but it tags in the Atlas. But it goes there also. So now, since we got this thing done, so now we can go to Atlas, and we can see what has happened.
You can just take a look at this table.
Sorry?
Okay, it's good.
Yeah. So if you see what's happened is, since we did a insert into this S3 bucket, as a part of the lineage and the tag propagation, the tags are already carried forward to the S3 side. And on the S3 side, on this one, you will see the same number of tags, like the sales tag is still the sales, but there's a subtle difference on the rest of them. That is because Privacy has a hook within Ranger and Atlas, so it knows that there's a UDF was called and the data was transformed, so it will translate from the CC to protected CC. So it makes it easier, because otherwise what happens is, if you're doing a C task and you're going to another table, if you're going to, and the same tag goes in after anonymization, you'll get double anonymization. So this sort of prevents that one. But in the case of S3, it's not an issue, because we are only worrying about the sales tag. So what's going to happen is, since this particular path has been tagged with sales, the S3 policy sync will look for this notification. As soon as it gets a notification, you'll find out all the policies for this sale, and it'll apply on this one. Okay? So what we can do is, we can go to S3 now, and we can see the policy. So you'll see two set of policies out here. One is the allow policy for Sally and Mark. Okay? And you'll see another set of policy for Henry, which is deny. So these two policies were set up in the Apache Ranger tag-based policy, access policy. So it automatically gets carried forward. So in this way now, if Sally or Mark, they do want to do some Spark job, anything, they'll be able to access it, but Henry will not be able to access it. At the same time, we also had another requirement that the data should be anonymized if it is in the cloud. So what I can do is I can go to S3 bucket. They have a very cool feature where I can do a preview.
Come on.
So what you'll see that the data which was in clear form in the on-premise, so when it came to the cloud, it is automatically anonymized. So with this, even for some reason, someone gives permission to this bucket outside Ranger, even they access it, they will not be able to see the clear data. Okay? So this is the end of the demo. I got a couple of more slides. I'll just go through it before I open up for questions. So out here, we use Hive primarily to do the data movement, but you are not restricted to Hive. You can, if you have a microservices like Kafka, everything, you can use Kafka Connect. So Kafka has an architecture of Kafka Connect has an architecture called source and destination and transformer. So you can have your code within the transformer as a plugin, which will do the same thing, will do the anonymization, and also make an API call to Atlas and set the tags. So as soon as the tag is set in the Atlas, it'll go to the Kafka topic, and the sync will automatically copy forward the policies. NiFi has a concept of processor. You can use the Spark UDF. And also, if you're having your own ETL process, you can use the APIs from Ranger and Atlas to do the integration. There are a few open issues and challenges. First of all, Ranger supports both tag-based policies and also resource-based policies. But moving the resource-based policy is a bit of a challenge, because there are many resources, and also it can be pretty painful to support some wildcards and other things. Out here, we are doing a one-way sync, that from whatever that is on the Hadoop side, on the Ranger side, is moving to S3. But if you're changing S3, it will not come to know. But if you're already anonymizing it, you're pretty much OK, because they can't see the actual data. There are a few limitations on the S3 side or AWS side. One is the group level mapping is not exactly the same. The way it is in LDAP is not the same in AWS. And also, there's some limitation on the size of the JSON or the permission JSON. So you had to do some optimization and make a compact JSON out of it. Most of the work is already done in open source. There is a couple of Jiras on the S3 side. From the Atlas team, I don't know Barbara is out here or not. She has done the type dev for S3. And also, we have a service dev right now just under review in the Apache Ranger for the S3 service dev. Okay. And so if anyone is interested, feel free to contribute. So we got like another 8 or 9 minutes. We can open up for questions. Yeah.
Yes.
I have a couple, two questions real quick. First, you had S3 up there, but I didn't see object storage for ADLS or WASD. Is Ranger extended to them, or is that on the roadmap?
So from the design perspective, it's a very generic design, so you can easily do it. So traditionally, Ranger has been more of a plug-in architecture, where if you take Hive, HDFS, we actually embed our code within the process itself. So this is the first time you're doing it outside. So here what's happening, the sink is doing the policy set on a remote area. So it doesn't matter whether it's S3, it could be any other system also. So we can extend this to that also.
And the second question, is there a limit and potentially a performance limit on the number of policies? We're looking at potentially having thousands and thousands of policies.
Yeah. On the Ranger side?
On the Ranger admin side.
So
Right,
on the
so-
on the Ranger side, on the cloud side.
Ranger.
Ranger admin in general.
Okay.
I can take
Is
that.
there a performance limit on the number of policies?
No, we have customers who have done even up like 10,000 policies. So there's no performance impact. We have done a lot of work to address any, to make sure that the Ranger scales. Especially policy evaluation time, there is no issue at all because it's all in memory. It's very optimized lookup on which policies to evaluate. Some of the challenges were on the Ranger administration side and being able to read it from the database and serve it for the UI. We have done a lot of caching. Abhay, who sits here, so he has done a lot of work on it. You shouldn't see any performance impact on even like 10,000 policies. That said, we reviewed some users who are like thousands of policies. It looked like some of them could be a good candidate to use like macros. Then we ended up converting like 800 policies into one policy. So for example, Ranger in the policy resource, you can use some macros like current user who is accessing it. So if you want to have, let's say, a policy which controls a home directory for every user, then you don't need to create one directory for every user. You can just say /users and then a macro, and then that policy is applicable only whoever is accessing that, it'll automatically expand that path. Same way we can do for owner-based in terms of HDFS. You can set a policy for owners of the file separate using a macro. So you don't need to have multiple policies just as an option. Because having 10,000 policies, though Ranger can support it, it can become a manageability issue. You being able to search it and all.
Any more questions?
So there is any Ranger roadmap to support any other AWS components like Athena or Glue?
Yeah, I don't think there's going to be any challenges. The main thing is that the translations. So with this current design, you can have another one, and you can just set the policy. So Ranger automatically supports, like if you take Hive and HDFS, there are different set of policies, but you still use tag-based policy to address it. You'll end up doing the same thing. So we'll have another service dev with the appropriate access controller actions, and we'll take care of it. Okay, I don't know how much you're familiar with the Ranger. Probably we can take it offline.
Yeah, I'm pretty much familiar with Ranger.
Yeah.
So my question was, it does also support like services like Athena or?
It doesn't right now. So, but that's with this design, this is a new design we introduced. You can support that very easily now.
Yeah, the ACL sync is a new part here, which is it's not open yet, so we are working towards it. So this model can be extended to any other component as long as the other component has a notion of ACL, which can be set externally via APIs. Yeah. So what we need is you have some ACL permissions in the cluster. We want the same thing to be reflected in the cloud. So what we need is like S3 has APIs for us to set ACLs. As long as they have the ACL, the same model should work there. Yeah. Yeah. Yeah.
Let me take
Yeah.
it. Yeah. Sure.
So it pulls out the relevant Ranger policies out of admin
So what it's doing is actually doing. So the question is, how does Ranger, how does a sync process get the policies? So it's almost like a Ranger tag sync. So it gets the notification from the Kafka, but it makes an API call to Ranger admin to get the tags. So it knows the S3, it's just like your plugin would do, it's like a small plugin within this policy sync. It gets this thing.
Yes.
Yeah. But there are, we can do a lot more optimization once we look into some of the different use cases.
Yeah, I think I know where Abhay is coming from. Let's take this question. We'll come back if there's time there. Yeah. Yes.
Say you have an external table
Uh-huh.
in a file, and you ask one of the columns. You still can get to Spark in a file.
Yes. So the question is, if you have an external table and you're having a masking policy, but if you're using Spark, would you still get the actual thing? Yeah, the answer is right. It's because what's happening with the Spark is you're going to the file directly, you're bypassing it, but there are other alternatives available. So if you're using like a Spark thrift server, okay, which is like an equivalent of the Hive server too, but uses the Spark Catalyst engine, you can still enforce it. The Ranger plugin can be embedded within the Spark thrift server. So when you're making a call, it will be exactly the same as you are doing a beeline or a JDBC call. So you have that option if you want to.
So like, if you move the data from the S3 to some other S3 bucket, so it will de-anonymize the data automatically from the S3 bucket to another S3 bucket?
That's okay. So what happens if you move data from one S3 bucket to another? So if you are moving from one S3 bucket to another bucket, right? If it's already anonymized, it will still be anonymized. Okay.
It won't like
Yeah. So if you are using a Hive on that also, and you're going through some of this same infrastructure, then you have the option to de-anonymize if you want to. Then you have to go through some process, like a Hive process or something like that. Make sense? But if you're doing a straight copy, you will not. Yeah.
But it's not really de-anonymization, right? Because that assumes it's two-way. So we are not talking about one way you anonymize once you do it, you cannot go back. So you need to have the source data in raw form, or you need to have access to that to be able to see that.
Depending upon the encryption scheme, you can de-encrypt if you really want.
Right. Just want to make sure that, because that's a lot of people are looking for, and when we say anonymize, they don't want it to be.
Yeah, that's a one-way thing.
Yeah.
So that's why you have different schemes. You got encryption, you can tokenization, and you can do one-way masking. Any other questions? Okay. So how many of you guys have a hybrid environment use case right now? Okay. And so right now we are going with the path where we feel mostly the structured data is going to go and Hive will work. But do you guys have any other use case other than what we are focusing on right now? Or do you think this will solve your problem?
I think this is pretty much close to what our current use case is. Right now it's mainly structured data.
Okay.
And it's trying to figure out, A, how we can get it out to the cloud, and potentially even spin up, maybe accelerate it out to the cloud, and so the on-prem capacity do the heavy lifting.
Okay.
Okay.
So yes, I think this, and we are already implementing Ranger. We're just having to go back and tweak our Ranger implementation.
Okay. Yeah, for this one, we deliberately went for the tag base because it's much easier to manage. When you go to the resource base, you get a lot, as you're saying, you have thousands of policies and it's difficult to manage them. So this is a much more simplistic approach of solving it.
I do have another question.
Sure.
Have you thought about, and I want to make sure I ask this correctly, extending Ranger potentially to other platforms? Because one of Ranger's commercial competitors, if you will, allows you to tokenize data, and I can tokenize it on Teradata, Hadoop, SQL Server, and the same hash is used across all of them, and that's very beneficial to our users, right? Is there any thought to maybe having that, still have that tokenizing bit exposable maybe via an API so that like SQL Server can call it?
Yeah, I think it's time up, but so that is exactly what I was trying to mention out here. We can take it offline. So there are APIs available, you can use it, and you can do exactly what you are saying.
Yeah.
Okay. 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 Thank you, guys.
Thank you.